Hello everyone, my name is Safa Khmil. Today I will present my project titled Coexistence of Radio Altimeters and 5G Networks. This coexistence problem gained significant media attention, especially when several airlines canceled flights in the US following warnings from the Federal Aviation Administration. The concern is that 5G signals, particularly in the C-band, could interfere with radio altimeters, which are critical for safe flight operations. Radio altimeters are the only sensors on aircraft capable of providing real-time measurements of the aircraft height above terrain or obstacles. Operating in the C-band, they feed critical data to various safety systems, such as collision avoidance system, the terrain awareness warning system, and autopilot controllers. Interference from 5G system operating in similar frequency band has the potential to pose significant safety risks. If such interference interrupts radio altimeter functionality during flight, it could lead to collision with terrain or obstacle, thus endangering passengers and those on the ground. In this project, we propose a system where multiple 5G base stations, modeled as a Poisson point process, coexist with a single aircraft equipped with one radio altimeter and descending in a straight path toward a runway with a 3-degree elevation angle from the ground. Our analysis focused on mitigating interference that could affect the radio altimeter's accuracy. Therefore, we defined the performance metric as the probability that the interference power remains below a specified threshold. Our objective is to reduce this probability, ideally approaching zero, by implementing different shapes of exclusion zones around the aircraft trajectory. The first exclusion zone we propose is a rectangular shape, which offers uniform interference mitigation along the aircraft descent. However, to account for changing interference level at different altitudes and minimize constraints on 5G base station deployment, we introduce two additional more adaptive exclusion zone shapes, which are trapezoidal and triangular shapes. After running some simulations, our results show that dynamic exclusion zones effectively protect radio altimeters' accuracy while reducing the overall exclusion area. This helps balance radio altimeter safety with 5G network performance by minimizing the constraints on 5G base station deployment. Now, as a conclusion, we study a scenario where radio altimeters and 5G networks operate in the same region. Our primary goal is to assist and mitigate the interference from 5G base station to ensure safe radio altimeter operation. Using stochastic geometry tools, we propose optimized exclusion zones that balance radio altimeters accuracy with 5G networks performance. Thank you.